A 59-year-old man is brought to the emergency department with fever, hypotension, and confusion. Blood cultures grow Escherichia coli. He is diagnosed with septic shock. The patient's condition is most likely due to the release of endotoxin from the bacterial cell wall. Which component of the outer membrane is responsible for triggering this patient's septic shock? A. Porins. B. Outer membrane phospholipids. C. Antigenic O polysaccharide. D. Lipid A. E. Peptidoglycan. Correct answer D. Lipid A. Explanation D. Lipid A. Lipid A is the toxic component of lipopolysaccharide, LPS, in the outer membrane of gram-negative bacteria. It activates macrophages and other immune cells, triggering release of TNF-I and IL-1, leading to septic shock. A. Porins facilitate the transport of small molecules across the outer membrane but are not directly involved in shock. B. Outer membrane phospholipids, structural, not responsible for immune activation. C. Antigenic O polysaccharide, important for serotyping and immune evasion, but not toxic. E. Peptidoglycan, found in both gram-negative and gram-positive bacteria, not the major driver of septic shock. Question 2. A 42-year-old woman develops a fever and purulent discharge from her surgical wound. Gram stain of the exudate reveals gram-negative rods. The bacteria are resistant to vancomycin and other large antibiotics that typically target the cell wall. Which structural feature of gram-negative bacteria most likely explains this resistance? A. Absence of peptidoglycan. B. Presence of a thick capsule. C. Outer membrane containing porins. D. Lack of teichoic acid. E. Cytoplasmic beta-lactamase enzymes. Correct answer C. Outer membrane containing porins. Explanation. C. Outer membrane containing porins. The outer membrane acts as a permeability barrier in gram-negative bacteria. Porins regulate entry of molecules, often excluding large hydrophilic antibiotics like vancomycin, contributing to intrinsic resistance. A. Absence of peptidoglycan. Incorrect. Gram-negative bacteria do have a thin peptidoglycan layer. B. Presence of a thick capsule. Capsules protect against phagocytosis, not antibiotic entry. D. Lack of teichoic acid. Teichoic acids are found in gram-positive bacteria, so this is irrelevant here. E. Cytoplasmic beta-lactamase enzymes. These can degrade antibiotics but don't explain exclusion of drugs like vancomycin, which is too large to pass through porins. Would you like a diagram or table summarizing gram-negative